Hi, Algebra 2. This is Unit 8, Lesson 6, the quadratic formula. So this is something that should be familiar to you because you did it back in Algebra 1. So let's just start with exercise 1, which actually just wants us to solve for all values of x by completing the square. Okay, so just a quick little review of that. So to complete the square, I have x squared minus 6x, so I isolate those first two terms. I sort of move that 1 off to the side, all right? And let me just change pen colors. I take half of that middle term, the b term. Half of negative 6 is negative 3, and negative 3 squared is 9, so I have to add 9. But remember, whatever I add to one side, I have to add to the other side, all right? So I'm going to add 9 to the other side as well. Now, this is now a trinomial, which is perfect to factor, and the factors are x minus 3 and x minus 3, but I write that as x minus 3 squared. And then everything comes over to the other terms are going to come over to the right. So I'm going to subtract 1 equals 8. So I have x minus 3 squared equals 8. Now remember, to solve an equation that has an x squared, I'm going to take the square root. So I take the square root of the left and I take the square root of the right. So taking the square root and the squared cancel out, and I'm going to write up, no, I'll write one more down here. X minus 3 equals plus or minus the square root of 8. All right, so now I have to simplify square root of 8, and I'll do that up here. So I'll start it down here. So that's the square root of 4 and square root of 2. Now the square root of 4 is equal to 2. So that's plus or minus still. Square root of 4 is 2, and then the other one is radical 2. Okay? And then I have to bring that 3. I'm solving for x, so I'm going to add 3, bring that over to the other side, and I get x equals 3 plus 2 radical 2. And x equals 3 minus 2 radical 2. So those are my two solutions. All right. Now, this whole process of completing the square, that's where the quadratic formula comes from. So just a review of the quadratic formula. First off, our quadratics have to be in standard form. And that standard form is ax squared plus bx plus c. So the number in front of the x squared is known as my a, the number in front of the x is known as my b, and the number by itself is my c. And then this is my quadratic formula. It will solve any quadratic equation. All right, so let's practice it again. So actually we're going to do the same problem, but with the quadratic formula. So I'm just going to list my a is 1, my b is negative 6, and my c is 1. So x equals negative b, so negative 6 is positive 6, plus or minus b squared, so negative 6 squared is 36, minus 4 times a, which is 1, times c, which is 1, over 2a, and again, a is 1. So this is just equal to 6 plus or minus, and 36 minus 4 is 32. Okay, and then I'm going to simplify my 32. So let's do it up here. So 6 plus or minus, the 32 breaks down to 16 and 2. And the 16 is my perfect square, it equals 4. And now I can cancel. So 2 goes into 6 3 times and 2 goes into 4 twice. And look at that, I have the same answer that I had up above. Okay? Number 3 is a multiple choice problem. So again, I'm going to use that quadratic formula. X equals negative b. Well, I can write down what my a, my b, and my c are if anybody is needing that information. So a is 1, b is negative 10, and c is 20. So it's negative b. So that's going to be positive 10 plus or minus b squared, negative 10 squared is 100, minus 4, a is 1, c is 20, over 2a, and a again is 1. So now it's just a matter of simplifying that. So under the radical, I have 100 minus 4 times 20 is 80. So 100 minus 80 is 20. Okay, and then I have to break down or simplify that 20. So that breaks down to radical 4 and radical 5. And then the radical 4 is equal to 2. And now I can simplify. So 10 divided by 2 is 5, and 2 divided by 2 is just 1, although I don't need to write the 1. But I'll write it just so you guys can see it. And that is my answer right there. So we can see that in choice 4. Okay? All right, let's see what we have on the back. So if you flip this over. So although the quadratic formula is most helpful when a quadratic expression is prime, not factorable, it can be used as a replacement for the zero product law in cases where the quadratic can be factored. So even if you can factor it, you can still use that quadratic formula. So let me show you. I'm going to do it first by factoring, and then I'm going to do it first by the quadratic formula. All right, so my factoring, for this I would have to do my AC method. All right, most of you are doing, I was just going to do it factor by guessing, but you guys, most of you use AC method, so let me do that as well. So the AC method, 2 times negative 6 is negative 12. Okay, AC, 2 times negative 6 is negative 12. I'm looking for the factors of negative 12 that break down to 11, so that would be 12x and negative 1x. So I'm going to take that 11x and rewrite it. 2x squared plus 12x minus 1x minus 6. So all I did was rewrite the 11x. And now I can factor by grouping. All right, so I'm going to factor out a 2x, and I'm left with x plus 6. And then here I also have to be left with x plus 6. So the only way that's going to happen is if I factor out a negative 1. The GCFs are put together, and that's one of my factors, and the other factor is x plus 6. And then I just set each of these factors equal to 0. So 2x minus 1 equals 0, and x plus 6 equals 0. So my answers are 1/2 and negative 6. Now that same problem can be done with the quadratic formula. So A is 2, B is 11, and C is negative 6. Negative B, negative 11, plus or minus B squared, 11 squared is 121, minus 4 times A, which is 2, times C, which is negative 6, over 2A. And then I just have to clean that all up. So 4 times 2 is 8, 8 times 6 is 48, and that's going to be a positive 48. 121 plus 48 is 169. Now we already can see from my answers already that my answers are not going to be a radical. 169 is a perfect square, so I have negative 11 plus 13 over 4, okay, because 169 is equal to 13, and negative 11 minus 13 over 4. So negative 11 plus 13 is 2, and 2 over 4 is 1/2. There we go, same answer. We knew they should be the same. Negative 11 and negative 13 is negative 24, divided by 4 is negative 6. So if you prefer, and you don't like factoring, you don't like that AC method, you can always use the quadratic formula as well. All right? So make sure that you do know that quadratic formula. We'll just try A and B. We won't try C and D, just to make sure that we got this. And then, of course, we'll be practicing this tomorrow. So A is 3, B is 5, C is 2. X equals negative B, negative 5, plus or minus B squared. 5 squared is 25, minus 4, A is 3, and C is 2, over 2A, and A is 3. So the hardest part is really just making sure that you can clean up that middle part. Negative 4 times 3 is negative 12. Negative 12 times 2 is negative 24. And 25 minus 24 is 1. And the square root of 1 is just 1. So really it's just negative 5 plus 1 over 6, and negative 5 minus 1 over 6. So this gives me negative 4 over 6, which is negative 2/3. There's one answer. And this gives me negative 6 over 6, which is negative 1. All right. So this one I could have factored. X squared minus 8x plus 13, I can factor, so you're going to see my answer will have a radical in it. So A is 1, B is negative 8, C is 13. So x equals negative b, so that's going to be positive 8, plus or minus b squared, negative 8 squared, and that's 64, minus 4, a is 1, c is 13, over 2 times a, which is 1. All right, let's clean up everything under the radical. Negative 4 times 1 is 4, and negative 4 times 13 is 52. So 64 minus 52 is 12. I'm going to break down the 12. The 12 breaks down to 4 and 3. And 4 is equal to, oops, wait, that's positive 8. 2 radical 3. Now once I have that 2 in front, now I can simplify. I couldn't simplify before. So 8 divided by 2 is 4, and 2 divided by 2 is just 1. And I don't have to write the 1. And there's my answer. Okay, so we will practice some more of the quadratic formula tomorrow in class.